As a means of preserving the heritage of the vintage engines, many owners will painstakingly restore their engines to full working order and present them in the condition they were when they left the factory. And as a result, it's not unusual at many shows and rallies to provide an area where stationary engines, as they're known, can be put on display, often driving pieces of associated machinery, as an idea and a mark of respect for the pioneers that helped produce these wonderful old engines. This International engine, built by the International Harvester Company in the United States, is just one of many. Another engine built by the Associated Manufacturing Company, a company that became known as the Amanco Company, again originally from the United States. These engines, often very basic in their construction, open crank with grease type lubrication for lubrication of the bearings, very basic ignition systems, but having said all that, they still proved to run for many, many hours and many years. A lot of portable engines were put on trolleys and trailers. An engine such as this, although mounted on a trailer, would have been permanently installed in an engine house. For display purposes, the engine and the trailer is jacked into position, the exhaust is attached. An exhaust such as this, with the silencer at the bottom there, would normally have been buried in a pit. Jacks are placed into position on the trailer, as an engine of this size would tend to try to move considerably. Prior to starting, the flywheel and piston has to be lined up in the correct position. A typical lineup of engines would see many different types and sizes. Oilers have to be lubricated. In this case, a glass-sided oiler with a drip mechanism will allow oil to drip carefully onto the bearing, providing lubrication. An engine such as this would produce about 1.5 to 2 horsepower. This particular model was built by Petters of Yeovil in Somerset. These Petters engines found themselves on many pieces of machinery. They were extremely popular in hay elevators and found their way into portable milking bales. Another such engine, of around 1.5 to 2 horsepower, is the ever-popular Lister D, as it was known. Built by R.A. Lister and Company of Dursley in Gloucestershire, many thousands of these engines were used reliably by manufacturers of milking bales and the likes, and other machinery, and they proved to be a very reliable and popular engine.
Take that on again. You want a box in the front?
This open crank engine, which is hopper cooled, is possibly an Amanco, produced by the Associated Manufacturing Company. Engines were mounted on trolleys such as this, as a means of having one engine to drive various pieces of machinery. Different companies manufactured them in different sizes, and this engine would be about 3 horsepower. The 2 large flywheels meant that the engine could run smoothly and at low speed. The exposed valve gear required the minimum of maintenance. The carburetor was very basic, although the bucket wouldn't have been standard. Ignition could be like this via a high-tension fleck magneto, as it's known, using a conventional type spark plug. Cooling via the two hoses which fed to a large water tank. And the engines in large factories were even used to provide the hot water for the factory. This hopper-cooled engine is driving a water pump. Many of the engines were similar in style and design, all having little differences to overcome the patent system, which meant, of course, a manufacturer had unique control over that design. A small water pump like this would have been used on a farm for supplying water for animal use, and even the house. The method of governing or engine speed control can just be seen on the right-hand flywheel there. The side valve mechanism, simple, basic ignition system, basic cooling system consisting of a hopper filled with water, and a very simple carburetor. All led to reliability. For maintenance purposes, the spark plug was also easily accessible. This open crank International engine is a good example of how the engine can be used to provide power via the belt pulley. In this case, another water pump. The valve gear can clearly be seen, and in this case a mechanically operated exhaust valve is shown. This Petter's engine driving a water pump. Another example of open crank engine. This time rated at about 1 horsepower from the associated line. Early engines such as this Amanco used a low tension ignition system consisting of a pair of contacts which, when opened inside the cylinder, would produce a spark. The spark, or the energy for the spark, was created by a low tension magneto which was driven via skew gears from the crankshaft. Oilers were also required and had to be adjusted and filled. Another example of a two-stroke engine put to use is this crop sprayer or dusting machine. A small engine was used to drive a fan which would apply chemicals to crops and orchards for killing off pests and parasites. The container there for the chemical, with a tap to control the amount of spray that's applied. Another example of Lister engine, this time showing the rather basic fuel pump. This pump would pump fuel continuously from the tank to the carburetor, where when it reached a certain level, it would flow back to the tank and keep continuously circulating, thus ensuring a supply of fuel for the carburetor. Another option example is the old Pyrene fire extinguisher. Showing the hit and miss governor there and the unusual popping sound it creates. Once the engine reaches a certain speed, the governor would throw out and disengage the mechanism, turning off either the spark or the fuel supply. In this case, the exhaust valve is held open, allowing the engine to freewheel on the strokes that were not producing power. The crank guard there was fitted so that as oil flew off of the big end bearing, it didn't fly all over the place, but would be retained inside the open crankcase by that cover. The camshafting gears there can clearly be seen to operate the valve ignition mechanism. In this case, a Wico flick magneto. Another larger trailer-mounted engine, this time a Ruston and Hornsby. These larger engines would have been permanently housed in engine houses and sheds and possibly used in large engineering factories. Roller cams were used to cut down on friction and ensure engine life. The governor weights were enclosed inside a case so that if they should overspeed and explode, they would be contained within the case itself. This type of engine uses a blow lamp to preheat the cylinder head for combustion. Fuel again is pumped continuously through the fuel system. The governor housing there is showing the casing. The bob weights would be inside. The connecting rod and the base of the piston can be seen. And these larger engines, of course, were not high revving machines. Their speed was quite slow. As in most applications of engines, an engine man was required to make sure the engine was lubricated and watered and kept running, and often would require continuous minor adjustments. Most engines were hand-started, either via a starting handle or by flicking the flywheel. And providing fuel and ignition was in order, the engine would start quite readily. This example of a Lister D engine, manufactured by R.A. Lister, also showing their sheep shearing equipment. This method was used to transport sheep equipment into the fields where they could be set up and used rather than bring the flock of sheep home to the farm. In this case, this engine would drive 2 combs and cutters via the flexible drive shafts from the top of the mechanism. And this whole arrangement was built by Listers of Dursley. Power was taken from the engine via the flat belt to the 2 pulley wheels on the top, which would then drive through the flexible shafts via small clutches. Another example of an engine driving a 3-cylinder water pump, this time a Wolseley, built by the old Wolseley Car Company. And the idea of the 3 cylinders on the water pump is to ensure continuous pressure through the pipes and not a pulsing effect that would otherwise occur. This engine, although early in its style and design, uses a high-tension ignition system. One of the alternative methods of high-tension magneto was the Wico snap mag. These magnetos were quite unusual in that they were pulled apart, and as they were pulled apart, they would generate a high-tension spark. Always time for discussion. Moving on to another display at Swansea. And this time, even the model enthusiast is catered for.
I hang the brushes, I don't put them on the board, see?
One such manufacturer of small engines such as this, miniature steam engines and stationary engines, were Mammoth. This display clearly shows the variety that was produced by the company. Majority are miniature steam engines and all in full working order. It usually takes considerable effort to handle one of these engines, as despite their relatively low power output, they were quite heavy. This little generating set is a type that was often used by the military and consists of a Norman twin-cylinder horizontally opposed engine and generator mounted on the rear. These little units were often used for emergency lighting and for home lighting in situations where mains power was not available. Power output would be dependent on the type of generator fitted and could be anything from 25 volts up to 240. And the object of using a twin-cylinder horizontally opposed engine meant that the engine would run smoother and reduce the flickering effect that a single-cylinder engine produces when driving an alternator. Not in the case of this engine, but these little engines could at times be very, very temperamental, and particularly didn't like starting again when hot. In this case also, the flywheel not only served to carry the engine over its dead stroke, but acts as a cooling fan as well. Another example of Ruston Hornsby engine, this time petrol engine. Again open crank and hopper cooled. And again a chance for discussion. All parts have to be regularly oiled and lubricated to prevent wear and seizure. The oil dripper, or glass lubricator, was usually used to lubricate the piston. Clear view there of the flick magneto. This magneto has a spring and armature which is flicked by a cam to produce a high tension spark. And of course the famous name of Ruston there, clearly seen on the crank guard. Little pipe at the bottom there is to drain the surplus oil out of the crankcase. This Ruston Hornsby engine, the hopper cooled type, Lister engine, an International Harvester showing their logo. The International Harvester Company spans the world. That was the old style logo for the earlier International Company. They later changed to the plain IH. But even companies' logos were a work of art in their day. This time the fuel tank is below the engine. It's filled with fuel and sucked up through a basic carburetor mechanism. Cunningly disguised as part of the flywheel is the starting handle in this case, which is pulled out of the flywheel for cranking purposes, and once the engine is running, the handle will fold itself back into the side of the flywheel. This was clever in the fact that it meant you didn't lose the starting handle. This time the power is not taken directly from the flywheel, but through to a geared shaft on the other side of the engine. The application this time is a vacuum pump for operating a milking machine. And once adjustments have been made to allow the right amount of fuel for the speed that the engine is running, it will then run happily at that speed continuously. Water needs to be added to the hopper for cooling purposes, and this is allowed to boil away gradually as the engine is running. And of course does require regular topping up. Another example of Petter's products, this time a Petter's two-stroke engine. This one I believe is known as the apple top engine, as the hopper is shaped similarly in style to an apple. These engines, of course, were built by Petters and Company of Yeovil in England. This time ignition is by a BTH high-tension magneto, BTH, which is British Thomson Houston, and to ensure that the engine is lubricated continuously, visible oil lubricators are provided. Again, for draining the crankcase, a small tap is inserted at the base of the crankcase. The engine again is mounted on a trolley, usually with steel or solid type wheels. This engine again uses the circulatory type of carburetor. Adjustment for starting and running is usually via a very crude tap assembly. These engines were quite high speed, and the governing was usually of a hit and miss type, which caused the engine to make lovely popping sounds and usually blow smoke rings from the exhaust. Engines also fall basically into two classifications of layout, that being a horizontal and a vertical type engine. In the vertical engine, the piston moves up and down, and in the horizontal, the piston moves from side to side. Small engines were also used for varying products such as driving sheep shearing machines, lawn mowers and the likes. And the smaller the engine, they were usually more high speed. This time a small air-cooled engine, and the fan blades and the flywheel can clearly be seen there for cooling purposes. Example there of a small tank-cooled engine. And the flywheel, of course, was usually one of the heaviest moving parts of the engine. Engine manufacturers would often manufacture their engines in various sizes to suit the power requirements of the customer. And this one is known as the Hired Man, built by the Associated Company, or Amanco as they were known. And the idea was to give the prospective purchaser an idea of just how much power the engine could produce. Different types of engines are brought from all over the country and exhibited to show some of the history and development of how the stationary engine was built and the purposes for which they were used. This particular outfit is possibly all built by the same company, and that Bentols were manufacturers of all types of machine for processing root crops and the likes, and they also produced a stationary engine as well. And this meant the company could not only produce the machine, but produce the power to drive it. And this is the open crank Bentol engine. Whether the company produced it complete or purchased parts from other manufacturers and marketed under their own name is unknown. As you can see, E.H. Bentel and Company Limited were from Heybridge, Malden, England. And using again the side valve mechanism, but this time the valve gear is under the cylinder. This company also used high tension ignition. Power again, this time via the flat belt to the pulley wheel of the root pulper. Clear view of the cam mechanism there, which was required to operate, in this case, the inlet and the exhaust valve. This Petter AVA2 engine, built by Petters of Yeovil. These engines were of the much later diesel type, and this could produce 10 brake horsepower at 1500 RPM, and is, as the model number implies, AVA2, a twin-cylinder engine. Many of these engines would be fitted onto machines such as balers, also widely used on generating plant. The two levers on the top there are for decompression purposes, so that the engine can be cranked by hand prior to starting, as the compression ratio in diesel engines are much higher than that of petrol. In the case of the diesel engine, of course, a fuel pump is used to inject fuel directly into the cylinder at the right moment. This again is an example of an air-cooled engine. Petters later went on to become amalgamated with Lister and become known as Lister Petter. This French-made Bernard engine was made in 1924 and would develop 3 horsepower at 950 RPM. It's now been fitted onto a framework to drive a water pump. This is an engine again of vertical design with overhead valves, the 2 valves being operated from the camshaft via push rods. Power again is via a belt pulley. Shell, one of the manufacturers, it manufactured Motor Spirit as it was known, and usually these brass caps would appear on the fuel cans that was provided for the carriage of fuel. The water which this engine is pumping is also used to cool the cylinder. As with all engines, regular lubrication is required.
This particular engine is the last generation of steam winding engines made to raise and lower cages into and out of coal mines in Britain. It was manufactured by Worsley Main of Wigan in 1927, and you can see from the size of it, the mass, the scale needed of engine needed to actually raise and lower cages and men a half a mile down into the coal seams here at Kevin Coyd Colliery. The drum has a diameter of 18 feet and a circumference of 54 feet. And you can see that the winding ropes which were on it would have had to be very strong. In fact, they had a breaking strain of 234 tons. And two of these ropes would have been on this engine, one overlapping, one underlapping, where as one cage came up from the bottom of the shaft full of coal to the top of the shaft, the other cage would have been going down with empty trams, taken down, the trams taken off and taken in to be filled and brought back to the pit bottom. The men who actually worked these engines, the winding men, were a very special breed. They weren't actually members of the National Union of Mine Workers. They had their own union, and of course they had a highly responsible job. These engines, as I said, were the last of the steam winders. From the 1930s, they were replaced by electric winding engines, which were much smaller and much less spectacular. But I think that this engine, one of only 3 or 4 left in Britain, in place in Britain, is a representation of the height of the mechanical abilities of industry in Britain to actually produce machines for the task in hand. Another steam winding engine on display at the museum, in contrast, is one of the earliest examples of steam winders used at a coal mine in South Wales. This small steam winder was brought to the museum from Morlais Colliery in Llangennith at its closure, and is over 110 years old. Manufactured in Scotland, it was actually used in a drift mine rather than a shaft, and the size of the engine reflects the fact that it had a lot less work to do at a much shallower depth than the huge winding engine which is actually on site here at Kevin Coyd.
Abergavenny often sees the site for the annual rally, where not only steam engines but stationary engines are also on display. An example there of early hand-operating sheep shearing machinery. Various methods of shearing sheep were produced, often requiring the power to be provided by hand operation. This application shows a small engine which is attached to a piece of wood or even a gate, where it could be transported to the field and used for sheep shearing purposes. Different examples again and methods of providing power for sheep shearing applications. 2 examples of Lister D there. An example of the combs and cutters used. These could be different types used for horse and sheep. And the machine there used for actually sharpening the cutters. The table would turn, the cutters be held on, and an abrasive solution applied to regrind the cutters. Example of a smaller, more compact Lister shearing outfit. This particular example would have been belt driven, rather V-belt pulley on the end of the crankshaft. And of course it was capable of driving 2 handpieces. Another example of Lister shearing mechanisms. course the much wider flat belt pulley to drive the two shearing heads. In general, a wonderful selection of sheep shearing machinery. Example of little and large there. Some of these small engines were built as apprentice pieces and often a working model of the real engine produced for sales purposes by the engine manufacturer. Again, showing a clear view of the bob weights there used for governing purposes. This time the governor would control the cam mechanism. Engines were also powered by gas, this time although powered by modern liquid petroleum gas. A special device instead of a carburetor was used to allow gas to be fed into the cylinder for combustion purposes. Of course, being gas, it's reckoned they ran a lot cleaner. One of the larger Amanco engines, this time 4 horsepower, built in 1915. And again, same design as the previous models, but this time everything upgraded and built larger to produce more power. Again, still using low tension ignition and hopper cooling. Clear view of the igniter as it's known. You'll see when it flicks, the contacts which are inside the cylinder break apart and produce a small spark as they break, and this spark is sufficient to ignite the fuel-air mixture in the cylinder. Another view of the Amanco engine, this time driving a water pump. Again, power is transmitted via the belt pulleys. For exhibition purposes, pumps were often staked into the ground like this to ensure the correct tension on the belt to enable the power to be transmitted. This time the water is circulating through a milk churn. Give an example of a milk cooling apparatus. This apparatus would have been used for cooling milk after milking time and prior to being churned and collected via the dairy. Another example of a large generator, this time using a Crosley engine. These engines were known as semi-diesel engines, and they required a large blow lamp or similar mechanism to heat the combustion chamber in the cylinder. This combustion chamber had to be preheated in order to initiate combustion, but once to the correct temperature and the engine running, the heat could then be removed and the engine would then continue running on its own. Fuel systems had to be primed. And the starting ceremony was often quite an elaborate ceremony to watch. Again, the large flywheel can be seen to ensure smooth running and carry the engine over the dead strokes. That's the strokes that don't produce power. With a bit of help on the flywheel. This time the crankshaft extends right through the alternator or dynamo where the starting handle is applied. And providing everything is at the right temperature and the fuel system has been primed, the engine should start and run. This particular one doesn't seem to want to go. In this case, the generator is direct coupled to the crankshaft, but the provision of a belt pulley is also there, so the engine could also be used to power belt-driven machinery. Flywheel is just being turned to make sure the cam is in the right position so the hand primer can be operated. This again is an example of a small two-stroke engine, ex-lawn mower, this time with a kickstart. And this time it's being used to power a small 12-volt generator, possibly ex-motor car. Another example of the Lister D engine. This time driving a miniature model of a traction engine. Steam engines are also included in the industrial engine classification, as the initial engines were not self-propelled, but were actually moved around by horses. Another example of milking machinery, this time the vacuum pump, being engine driven, and this outfit built by Gascoignes. Gascoignes are one of the companies that specialised in producing milking equipment and building and installing milking parlours on the farm. Cups there would have been attached to the teats of the cow, and of course then the milk extracted into the buckets and later put through the milk cooler, and then it would be churned or collected in the churns, ready for collection via the dairy. Wolseley engines, one of their models was the WD, so called because it was built for the War Department. They had many engines built by Wolseleys and were usually in a grey livery. Engines also ran on hot air, and this is a hot air engine using what is believed to be the Heinrici principle. This particular one is an Ericsson hot air engine, and despite its size, a small amount of power was produced, and they were used mainly for such purposes as this, that is pumping water. The mechanism is completely different to that of a steam engine or petrol engine, although pistons are still used. But it's relied on the heating and cooling of air to create expansion and contraction to produce power to turn the flywheel and crankshaft. In this case, the heat or hot heat supply is actually housed in the firebox at the bottom of the cylinder there. And the cylinder is surrounded by water for cooling purposes, and this rapid cooling caused a vacuum to be created inside the cylinder. And with careful control of valves and mechanisms, motive power could be produced. So much so, it could even send you to sleep watching it. Another example of a lighting plant there, this time built by Stuart. Stuart built water pumps and small engines and small generating plants. And they usually used a small two-stroke engine. This time a small pump was used for circulation of fuel or water around the engine for cooling purposes. And the pump, of course, was driven from the engine itself. More examples of the exhaust, this time from a two-stroke engine with a hit and miss governor. The engine in question looks to be a Petters manufacturer's two-stroke. And these two-stroke engines, of course, were much higher revving than the contemporary four-stroke. Of course, the larger single-cylinder engine would need to be bolted down to a secure base, as they could easily move and break away from their mountings. This Whitty drag saw engine, of Canadian origin, would have originally been attached to a large reciprocating saw and would be used for cutting and logging of timber. An example of a foreign engine there, a Waller engine. Even lunch has to be taken whilst watching the engines. The plastic duck and the boat are put in the water tank just as a means of attracting a bit of attention and a little bit of fun. Usually the tank-cooled engines were not meant to be moved around, but this is an adaptation to enable the engine to be moved from one machine to another.